Hello, my name is Damien, and this is my cool little school project for my class. And, this is not only a video for the class to see, but also a video on my channel for everyone to see. So let's get started on specifically, what is a solar eclipse? A solar eclipse happens when at just the right moment the moon passes between the sun and the earth. Sometimes the moon only blocks part of the sun's light. This is called a partial solar eclipse. Other times the moon blocks all of the sun's light, and this is called a total solar eclipse. Alright, now, as you can kind of see here in this diagram, you can see the Earth is here, then we got the moon casting its shadow, and then, of course, the light coming from the sun. Now, the full shadow is called the umbra, and this is basically the area that shrinks onto the Earth, and this is where the total solar eclipse part comes from. But there's also the partial shadow, which is where the partial eclipse happens, and this is called the penumbra. And yeah, you can see here that it also comes from the sun's, it comes from the sun and all that stuff. Now, let's talk about lunar eclipses. A lunar eclipse happens when Earth is directly between the sun and the moon. Earth blocks the light coming from the sun, casting a shadow on the moon. The shadow makes the moon appear much dimmer, and sometimes the lunar surface turns into a striking red. So yeah, very similar to the solar eclipse, except instead of the moon casting a shadow, it's the Earth. Now, there is a total lunar eclipse that happens sometimes, and the total lunar eclipse is basically slowly the moon moves into Earth's penumbra and slowly darkens. Right before it enters the entire umbra, eventually it turns completely black and then all of a sudden turns into a striking red. So very similar, except it turns red rather than just being a black void that's blocking the sun like this. Now, we're also going to be talking about constellations. Now, I'm going to go right ahead and go with the Orion constellation that is in the sky, and I will be showing you some questions about it, and I will be answering them. Now, a constellation is a scientific word. It's basically a group of stars seen as forming a figure or design in the sky, especially one of 88 officially recognized groups, many of which based on mythological traditions from ancient Greek and Middle Eastern civilizations. Now, we're going to be answering some questions. Now, if you want to see exactly when Orion is best seen, usually Orion is most visible in the evening sky from January to April, winter in the northern hemisphere and summer in the southern hemisphere. Now, let's talk about seasons. Seasons are basically one of the four periods of the year: spring, summer, autumn, and winter. It is basically a special part of the year where each one has its own kind of weather due to Earth's tilt. Now, why do seasons even happen? Well, Earth has seasons because of its axis and the fact that it's actually tilted about 23.5 degrees. Earth's axis is always pointed in the same direction no matter what part of the sun's orbit that it has around it. So different parts of Earth get the sun's direct rays throughout the year. For example, in summer, the rays hit the region more directly than in any other time of the year. Right here, you can kind of see an example of what seasons are. You can see Earth's tilt never changes. The only thing that changes is the fact that over time, as it goes around the sun, you can very obviously see that Earth seems to change a little bit, but it's really not changing. It's just the Earth's tilt just stays the same. So the more it goes around the sun, the different it looks. When you look out onto the night sky, you'll see the moon takes a slightly different shape in the sky. These different shapes are called phases of the moon, and they change with a regular pattern over a period of about 30 days. The next phase is the waxing crescent moon. This is basically when the moon starts to kind of go around the Earth a little bit and starts to kind of show a little bit more of its reflecting light. The next phase is the first quarter moon. It may look like it's halfway across the Earth's entire orbit, but it's only 1/4 of the way around there. That's why it's called the first quarter moon. The next one is the waxing gibbous moon. Almost a full moon, except the fact that it's just a little more in front of the first quarter. So yeah, it's mostly there. Now we finally arrive at the full moon. Now this is when the moon is completely facing Earth. The part that is illuminated by the sun, the part that's facing Earth is completely illuminated by the sun, rather than the new moon. And now this is our first milestone, because now the moon is completely facing Earth and is halfway through its orbit. The next one is the waning gibbous moon. This is when it starts to shrink and go back down and getting closer and closer to completing its orbit. The next one is the last quarter moon. This is when it's halfway, but it's only there. Like, it's only 1/4 of the way back to resetting the whole orbit. We already got 3/4 of the way there, so that's why it's called the last quarter moon. And now we arrive at the last one as the waning crescent moon. This is the very final one, and this is where the moon finally ends up getting close to the new moon, and then it reaches new moon, which is where it resets, and the cycle continues. Now, you may notice that I've been saying the word orbit a lot, but what does it really mean? What is an orbit? Well, an orbit is basically a regularly curved path that one object in space takes around another one. The Earth takes about 365.25 days to complete one orbit around the entire sun, while the moon only takes about 29 days. Mercury takes 80 days, and Jupiter takes even 12 years. It's a long time. That's like 12 Earth orbits. And then Neptune literally takes 165 years to go around the sun just once. That's really unfortunate, man. This right here is a picture of the solar system. You can see a lot of things orbiting the sun. These are orbits. Now, the reason why we have days is due to a rotation. Now, the moon doesn't have a rotation, and that means it's tightly locked to something, which means it doesn't rotate. But the Earth does, which is why we have day and night cycles. A rotation refers to an object spinning motion about its own axis. Rotations refer to the object orbital motion about another object. For example, Earth rotates on its own axis, producing about the 24-hour day. Earth revolves about the sun, producing the 365-day a satellite revolves around a planet. Now, a rotation can take specific amounts of time. Earth takes about 23.25 hours to revolve around its axis, or rotate. Yes, I know it's technically 24 hours, but whatever. While Jupiter only takes 12 hours even though it's far bigger. This is a video of Earth rotating. Yes, it's not real time, but whatever. Earth spins or rotates around 23 hours per day. But if you want to be all technical, I guess you can go with 24, whatever. But anyways, that's it for this video. Hope you guys enjoyed this video. I hope I get a good grade on this project, and yeah. See you guys later. Bye!